Today we're going to talk about matrices. Now, the reason we're doing this is because you can use matrices to solve linear systems of linear equations or systems of equations in general. And if you happen to take linear algebra in college, your teacher will love you because you'll know how to do this already. It's a pretty long section, so I may record it into two parts. We'll just have to see. But a matrix looks like this, okay? It has braces, and they are, or not braces, excuse me, brackets. And they are brackets, not braces or parentheses or just lines. We draw them as brackets, okay, on either side. And they have rows and columns. So a row is across here and a column is going down, just as you would expect. So if we want to write example 1 as an augmented matrix, what we first need to do is make sure that this system is in the correct form. We need it X, Y, Z equals, okay? So the first row is 3X plus Y minus Z equals 0. So that one's all good. But the second row is not in order, so we need to put it in order. We've got 2X. We don't have a Y, so we'll say 0Y, and you'll see why here in a second, plus Z, and we're going to get that 4 over on the other side, so add it to equal 4. And then the last row also isn't in the correct order. We'll say 0x plus y plus 2z and get the 7 over by adding it. So now it's all in the correct order, and what we do is we start our matrix with our brackets, and we put a line close to the end because we're going to put just the coefficients of each equation into this matrix, just the coefficients. So 3, 1, negative 1, and on the other side of the line we put 0. Then for the second row we've got 2. We have to put a 0 in the Y spot, so that's why we included it up there. 1Z and 4. Then 0x, 1y, 2z, and 7. Example 2 wants us to go backwards. So write this matrix as a system of linear equations. And so a system of linear equation goes in one brace on the left. And we'll just write 4x. We're not going to put it in any weird order, just straight through, plus 1y minus 2z equals 6. Second row would be 3x. We don't have to worry about the 0y, so minus 3z equals 10. And then 0x, 2y plus 1z equals 0. Row operations. So there are 3 row operations you can do. You can interchange any 2 rows. You can replace a row by a non-zero multiple of that row. Basically, you can multiply the row by any number besides 0. Or you could replace a row by the sum of that row and a constant non-zero multiple of some other row. So, in other words, you can multiply, say, row 2 and add it to row 1 to get what you want. And there's a reason we do that, and you'll see why as we go forward in our examples here. So, for example 3, it only wants us to apply the row operation R sub 2, which means row 2. So row 2 equals negative 2 times row 1 plus row 2. So we've got our original matrix. And we're going to perform row 2 equals negative 2 times row 1 plus row 2. I probably need to leave that off for now. Okay, so what happens is row 1 stays the same. And notice I'm leaving some space here. Row 2, we do 2 times what's in row 1 plus what was already in row 2. For the second spot, we do 2 times row 1, the spot right above it, you can see, plus what was already in row 2, which was a 6. And then the last spot, I need to move my bracket over. 2 times row 1 plus, so row 1 is 1, plus what was in row 2, which was 8. And then we just perform that operation. So that'll give us still 1, negative 4, 1 on the top. On the bottom, negative 2 times 1 is negative 2. Negative 2 plus 2 is 0. 2 times negative 4 is negative 8. Negative 8 plus 6 is negative 2. And 2 times 1 is 2. 2 plus 8, excuse me, that's supposed to be a negative 2. So, already messed up there. Sorry about that. Negative 2 times negative 4 is 8. 8 plus 6 is 14. Negative 2 times 1 is negative 2. Negative 2 plus 8 is 6. And so that is the next step in our matrix. You'll see as we go forward that there's a reason we wanted this 0 there. Okay, we like to get zeros under the 1s and sometimes over them. Example 4 says find a row operation that results in this augmented matrix. Having 0 in row 1, column 2. Okay, so we're starting with our 1, 0, negative 4, 1, 5, negative 2. And we want a row operation that will end up with, let's take this on the next page. I'm going to run out of space. Okay, so we want a row operation that's going to end up down here with the bottom the same, but it wants a 0 in row 1, column 2. So we need to get a 0 right there. So that's the idea, to get a 0 there. Notice row 1, column 2. Okay, so keeping our bottom, how are we going to get a 0 right here? So, if there's only one way we can do this. We can't multiply through by 0 and get zeros on top. That's not allowed. The only way to get a 0 from a negative 4 is to add 4. Since there's a 1 on the bottom, we can multiply that 1 by 4. So multiply the 1 on the bottom by 4, and add it back to the top. And that's going to get us a 0 here. And so if we're going to, so that's our row operation. In row 1, we're going to do 4 times row 2 plus row 1. So 4 times row 2 plus, didn't leave myself enough space, row 1. And here, 4 times row 2 which was -2 plus what was in row 1 over here. Okay, so we've got 4 times 0 plus 1 is 1. 4 times 1 is 4 plus -4 is 0. There we go. 4 times -2 is -8 plus 5 is -3. And so the row operation that we used, our answer here in this particular problem, is that row 1 was 4 times R2 plus R1. Row echelon form is when we get a matrix so that all the numbers below 1 are 0. And then you get, that one should be 1, whatever number's over here. So notice this diagonal has to have 1s in it, and below the 1s have to be 0. That's row echelon form. And later we'll look at reduced row echelon form, where we'll also get the tops to be equal to 0. So let's start solving some of these guys. First thing we need to do is put this in matrix form. Everything's in order here, so that's good. We've got 1, -2, 3, and 7. 2, 1, 1, and 4, -3, 2, -2, and -10. So our first objective is to get zeros here and here. Okay? We can't get 1s along the diagonal, which we've already got some, until we get zeros there. We do have to make sure we have a 1 on top to begin with, but we do this time, so we're good to go. Okay, so since the 1 is on top and we're not doing anything with it, we're just going to keep what we already have up there. And then our next step is just going to stay the same. I'm writing out the middle steps for now. I may not do that the whole way through the notes, but I did on the notes that I've printed for you. So you can always look back at that too, even as you're going through the video here. So we need to get a 0 here. So let's focus on that. How do you get a 0 there when there's a 2 right now? 2 minus 2 is 0. So we take advantage of row 1. So in row 2, we're going to multiply row 1 by -2. We can do that because there's a 1 in the row 1 spot there. So we're going to multiply row 1 by -2 and add it to row 2. So I'm going to go ahead and just write this out. for each spot. There we go. Okay, so 2 times row 1, there's a 1 there, plus what was in the row 2 is 2. 2 times row 1, negative 2, plus row 2, there's a 1 over here. 2 times row 1, that's a 3, plus what was in row 2, a 1. 2 times row 1, which is 7, plus what's in row 2 originally, the 4. Let's go ahead and figure that out down here. So we're going to end up with 0, 5, negative 5, and negative 10. Then we're going to do something similar to get a 0 on the bottom row. So what makes a negative 3 0? Adding 3. So in row 3, we're going to 3 times row 1, because if we multiply the 1 by 3, it'll give us our 3. 3 times row 1 plus row 3. So 3 times row 1 plus, I'll write that all the way through. So row 1, 1 plus our negative 3. Row 1 plus what was in row 3. Row 1 plus what was in row 3. Row 1 plus what was in row 3. And hopefully I've done all my calculations correctly. I was very careful. So that's what you should get. 0, negative 4, 7, and 11. Okay. So that's all fine and dandy, but we are not done. We are not anywhere near done. We have to get 1s all through here and 0s underneath. So we've got 2 of the 0s. That's great. To get this to be 0, we first need this spot to be 1. Okay? Move this over a bit. So, we're only worrying about row 2 right now. We don't have to do a big amount of stuff, so that's why I'm not putting an extra area in there. Okay, so we've got to make this spot a 1. How can we do that? Well, we can multiply through by a non-zero number. So how do you make 5 a 1? Divide by 5. So we're going to, in row 2, we're just going to multiply everything in row 2 by 1/5, or divide by 5. So 0 divided by 5 is 0. 5 divided by 5 is 1. Negative 5 divided by 5 is negative 1. And negative 10 divided by 5 is negative 2. Okay, so pick that up. Take it to the next page. Thank goodness for copy and paste. And forward we go. Next step. We've got to get a 0 right here. Okay? No sense in worrying about the 1 here yet because, well, it'll just mess it up when we get our 0 on the bottom. Okay? So we're looking for something that will, and we're just messing with that bottom row right now. Sometimes we can do more than one row at once, but in this case, we can't. Okay, so we're trying to get a 0 right here. And there's already a 0 in the first spot, so we don't have to worry about that too much. Okay, so let's let the kitty out because he's meowing. If I can get the door open. Okay, so let's go ahead and set up our spot here. So we're just messing with the second row. So I'm going to go ahead and put the stuff up here for the first and third rows. Okay. Oh, no, we're just messing with the third row, aren't we? Okay, so I get rid of that. I always use pencils when I'm giving notes. Good hint. Okay, so something is going to happen to row 3. What is it? We need to get this spot to be a 0. How do we get a -4 to be a 0? We add 4. So how do we get a 4 there? Well, if we multiply row 2 by 4, since we've got a 1 there, and add, then we can get 0. So 4 times row 2 plus row 3. So 4 times row 2, there's a 0, 1, -1, -2 go in here. And then this is what we're adding. So 0, -4, 7, and 11. So on the bottom, in this spot, we've still got a 0. Now we've got our 0 here. In the third column, we're ending up with a 3, and then the last column, another 3. We are almost done, at least with the matrix. So now, remember, we've got our zeros on the bottom, but we need to have 1s across here. So we need to get this 3 to be a 1. So again, we're just dealing with row 3, so I'm going to go ahead and write down the other 2 rows. And so on row 3, how do we make this 3 a 1? We can divide by 3 or multiply by 1/3. So 0 divided by 3 is 0, 0 divided by 3 is 0, 3 divided by 3 is 1, and then this 3 divided by 3 is also 1. We now have our system in row echelon form, a diagonal of 1s and a triangle of 0s on the bottom. Now, how do we use this to solve our matrix? Because that's the whole, or to solve our system. That's the whole goal of what we're doing here. So, in this bottom row, notice we have our 1. Let's do this. The top row, if we change this back into a system of equations, okay? I'm going to start over here because I know where this is going. The top row would look like x minus 2y plus 3 equals 7. The middle row looks like y minus z equals -2. And the bottom row is just z equals 1. Notice the positive thing about this. We have one of the variables solved for. In the second equation, we can easily plug in and solve for the other variable. And in the third equation, we can easily plug in again. And I forgot my z right there. Okay, so if z equals 1, then y minus 1 equals negative 2. Add 1 to both sides, and y is negative 1. And if y is 1, then x minus 2 times negative 1 plus 3 times z, which was 1, equals 7. Which we can simplify. X plus 2 plus 3 equals 7. So x is 2. And now the other kitty wants out. But she doesn't go out, so I'm sorry. She should stop meowing soon. Willow. Willow. Shh. I tried. Okay. So the solution finally to our system is, in braces, 1, nope, not in braces, in parentheses, because it's a point, a three-dimensional point, 2 for x, negative 1 for y, and 1 for z. So we have finished our first system of equations solved with matrices. So let's go on and do another. And basically those are the steps which we're going through in examples, so we won't worry about that. Okay, so I'm going to solve one more here and then we're going to stop and I'll start again in a few minutes. So example 6. The reason I'm doing so many of these is just to help you, well, understand it, okay? If you understood it after that first one, awesome. You don't have to watch anymore. Just make sure, well, go ahead and watch this. Okay, so for this one, we need to make sure and we're in order. First thing, X, Y, Z. X, Y, there's not a Z, that's okay. X, Y, Z. Okay, so we're good there. And we make our matrix. 1, 1, 1, negative 4. 2, 1, 0, 0. 3, negative 1, 8. Okay? And remember our steps. The first step is always to make sure that we've got a 1 in this first place. And we do. So that's all good. Next is to get a 0 here and a 0 here. So down here, I'm going to end up with the top row being the same, and the bottom row we're going to have a 0 here and a 0 there. I'm sorry about the cat. I don't know why she's having such a fit. Okay, so what are we going to do? Let's go ahead and write this out. Okay, so how do we get a 0 in that second row, first column? Well, we've got a 2 there right now. So how do we get a 0? We subtract 2. So we need to, in row 2, do -2 times row 1 and add it to row 2. So -2 row 1 plus. I'll write this through. In the next video, for the last few examples, I probably won't write down this middle step, but I will for this one more time. Okay, so we've got 1, 1, 1, -4 going in there, and then this second row that we're adding. So 2, 1, 0, and 0. So we get 0. Yay. And then we have -1, -2, and 8. Now let's do the bottom. Remember, we need to get a 0 in the spot where right now there's a 3. How do we get a 0? Subtract 3. So -3 times row 1 plus row 3. -3 times row 1 plus row 3. My pencil just stopped working. Okay. So we have 1, 1, 1, -4. And then what was on row 3? So 3, -1, -1, and 8. So on the bottom, we now have 0, -4, -4, and 20. Next step is to get a 1. Okay, so first step is always to get zeros under here. Next step is to get your 1 there. Next step is to get a 0 there. And last step is to get a 1 there. So, how are we going to get a 1 in this spot? Just multiply by -1. So negative times row 2, and that will give us a new row 2. Okay, so we're just going to change the values of everything there. Okay, next we need to get a 0 right there. So down here, we're going to end up with, we're not messing with the first row. We're not messing with the second row. But we need to get a 0 there. Going to go ahead and write things out. Set us up so we're only focusing on one thing. And how are we going to change this -4 to a 0? -4 plus 4 is 0. So multiply row 2. We could do row 1 since that's a 1 up there this time, but that's just coincidence. So multiply row 2 for consistency by 4. So row 3 is going to be 4 times row 2 plus row 3. So we're putting that row in our parentheses here because that's what we're multiplying by. And then this row, we're adding on to what was in row 3. Oh, I jumped ahead. Should be 0, -4, -4, and 20. So that we get 0, 0, 4, and -12. Okay, are you catching on? So what's our next step? We've got our zeros in the triangle. Now we need to finish our diagonal of 1s by getting a 1 right there. So we're keeping our first 2 rows and getting a 1 in this spot. How do you make a 4 a 1? Divide by 4. So 1/4, let's say, R3 equals 1/4 R3. So 0 divided by 4 is 0, 0 divided by 4 is 0, 4 divided by 4 is 1, and -12 divided by 4 is -3. Now we have our system ready, or our matrix ready, to turn back into a system and solve. Okay, so we have, what did I do wrong there? Did I take the wrong picture? I must have. Let's see. Copy. Paste. There we go. Okay. So in row 1, we have x plus y plus z equals -4. In row 2, we have y plus 2z equals -8. And in row 1, we have z equals -3. So if z is -3, we're going to plug that in to our second equation. So y is, it should be -8, -2. And then we're going to plug in -2 into our third equation. So z was -3, y was -2, so x is 1. Therefore, the solution to our system is where x is 1, y is -2, and z is -3. That's our answer. Okay, so I'm going to stop here and then record the rest of this. You will need to watch the next one. I'm going to move through the actual steps a lot quicker, but you're going to see what happens when you have a dependent system or an inconsistent system, and how do you do reduced row echelon form. So it will be completely different stuff, so you will need to watch that video also. So we'll pick back up here in just a minute.